month's maths video. We're at Stirling University in Scotland, and I'm here with some friends. Everyone, say hello.
Hello!
Hello! There are 16 of my very good friends here, and they're forming a big circle. Now, I want you to estimate, just from this clip that I'm showing you, how many of them will it take to form across the circle? You see, I think I already know. Let's find out. Now, what we're going to do to find out, we're going to mark two opposite points of the circle. So, this is Douglas. Hi, Douglas. Hello. He's going to stand absolutely still here, and across the other side of the circle, this is Arthur. Yep. Hi, Arthur. Now, I wonder how many people it would take holding hands across that circle. So, let's find out. So, let's find out how many people it will take. So, would you like to hold hands with us, Douglas? Okay. So, would you come and hold hands? That's fantastic. That's 2. Would you come and hold hands, please? That's 3. I wonder how it's going to say. Would you have a little go? That's it. Okay. Looks like 4, not quite enough. 1 more. Would you have a little go? 5. Hold hands with Arthur. There we go. So 5 across and 16 round. So what is it with circles? Well, let's find out, because it really is a very interesting piece of mathematics indeed. Now, in our example, there were 16 people around the edge of that circle, and it took exactly 5 to get across the centre. And of course, we can predict that because of something found out by the ancient Greeks. But for now, I just want us to divide the 16 by the 5. Divide the circumference, if you like, by the diameter. And 16 divided by 5 will give us 3.2. Remember that number, because I want to give you another example. Here's another circle. 25 people standing in a circle, and that would take 8 across. Now 25 divided by 8 is 3.13, remarkably similar to 3.2. And it's this similarity that the ancient Greeks noticed. In other words, dividing the circumference of a circle by the diameter always gives approximately 3.14. And they thought this was so amazing, this ratio, they gave a letter to it, the Greek letter pi. Now, it's important at this point to say that our exercises were only approximations, but they were able to do increasingly clever methods to get it very, very accurate indeed. And this allowed them to make predictions. For example, if I know the diameter, I can work out the circumference using this famous formula. The circumference divided by the diameter is pi, so the circumference is always going to be pi times whatever the diameter is. In this example, about 47.1 units. And here's another thing you can try. Find a centre circle, maybe on a football pitch, and run across it, or walk, it doesn't matter, and then run or walk around it. And time how long it takes you to do both those things. You won't be surprised to know that dividing one by the other will give you a little more than 3. Pi again. But perhaps one of the most interesting and amazing things about pi is that it is what we call irrational. What does that mean? It means it can never be expressed as a decimal, however many decimal places you go to. Here are the first 1,000 places. Now I only know 3.141596535899732384626433, which doesn't even get me across the top line. I wonder how many decimal places of pi you can learn. And you want to know something else? Somewhere in pi, your exact mobile phone number will appear. Why? Because this goes on forever. That's pretty mind-blowing, isn't it? Anyway, see you next time.